Presentation here is a bit of a odd among all of them, because the common factor between all those presentations and my presentation will be only the thermal energy, which is common to both of us. And our way of using thermal energy is whatever is available given by the sun god that we utilize. I always believe that sun is the only god which keeps meeting you every day, because he has got all the properties and all the virtues of God, and he keeps meeting you every day. And that is why about say 12 to 13 years back, when I decided to diversify from civil engineering to some other sector, I decided on the solar. Our company's name is Clique Solar. We want to take the energy self-sufficiency from concept to reality. That's our motto. We have developed a technology called a solar thermal concentrator Arun, which concentrates the solar energy and can give the energy at about high temperatures, maybe about 400 degrees centigrade also. Basically, sun's energy is available in a very dispersed fashion. It's available in abundance, but it is in a dispersed fashion, and you are, for achieving high temperatures, you have to concentrate it. And that's the principle of our technology. We concentrate the sun's energy and deliver it at a very high temperature to the user. It can be given in a form of water, high temperature, high pressure water, high temperature, high pressure steam, as well as the thermocoil. Because it doesn't have any kind of loss in terms of geometric cosine angle losses, which are there for other technologies. Now, before starting to talk on the solar thermal assisted power generation, we have seen the emergence of PV, which is photovoltaic electricity, in the last few years. Compared to that, solar thermal concentrators have taken a back seat because of the high costs involved and PV prices going down. But still, we think that solar thermal concentrators, they have a certain role to play. And I will be touching upon various different technologies which can take part in various parts of the power plant, various processes of the power plant. Although I know that this is just the beginning, nobody has done it yet in India, and that is why it will require a lot of work and a lot of work together. Here, the major processes where solar thermal can play a role are basically processes 2 and 3, as in the earlier this thing, which is feed water heating. There can be always discussions on this, because there are two opinions on this, because feed water heating is not that easy, because the presence of economizer in the boiler definitely puts some restrictions on this, but still some work has to be done on both sides, on the power plant side as well as on the solar side, to achieve this, because it's a very great opportunity. And of course 82 megawatt thermal for feed water heating. Now, typical steam-based power plant with solar addition, what I propose is like this. This is solar field 1, which is parallel across the feed water heating, and also the small heating of the the bleeding of steam. That there also it can play important role, and of course the parallel to the boiler. Solar field 1, I am proposing three solar fields for any typical power plant. Maybe all are relevant for a particular power plant, or maybe one of them is relevant for the power plant. Solar field 1 is for 180 degrees to 120 degrees 10 bar, which is feed water heating, deaeration, steam ejector, space cooling, etc. Here Arun based tower system, because Arun can be also used as a heliostat, tower system and parabolic trough, these two technologies can be used. Solar field 2, which is 250 degrees, 270 degrees parabolic trough technology, which are already seen. Solar field 2 technologies are basically again heliostat and the LFR, which is linear Fresnel, where you can get the high temperatures. And solar field 3, we think that only the tower technology can succeed in giving the high temperatures and high pressure which are required. Now, scenario for feed water heating, if you see, if we consider say different scenarios of various different combinations, because naturally you cannot have the 100% replacement.